All right, Daniel, for today's lesson, it's called Learning to Multiply Traditionally on side 2 of the abacus. All right, so we're still doing multiplication. We are, let's see, we're still doing multiplication. We're going to use side 2 of our abacus, but this time we're going to, the way we write things down will be different. The way we handle it on our abacus, I think everything will be the same as what we did before, I believe. But the way we write it down is going to be different. Okay? So let's see what this looks like. We're going to be doing the multiplication problem. 2,736 times 3. Ignore that little, arg. Don't be doing this. Anyway, let me do that. Okay, ignore that little period right there. That doesn't belong. But anyway, 2,736 times 3. That's the problem that we're going to work on. We're going to learn how to just write down the answer. Okay, so this time, remember last time we wrote down the partial products? Okay, so this time we're not going to write the partial products. We're just going to end up writing the final product. Okay, so a little bit, you can think of it as a shorthand way to do things. So you're not writing as much, taking up as much paper as you otherwise would. Okay, so let's take our abacus. Let's put all of our beads in the center or middle of the abacus, side 2, and let's go ahead and enter 2,736 at the bottom. So bring down the beads that you need to bring down so that you have 2,736 at the bottom. And so your abacus should look something like this, the one that I have pictured on the left here. 1, 2, 1,000, 1, 2, 3, 4, 5, 6, 700, 1, 2, 3, 10, 1, 2, 3, 4, 5, 6, 6, 2,736. Okay, so that's how we're going to start. Well, same process we're going to follow here. We're going to take each place in our 4-digit number and multiply it to the 3. Okay, so we're going to start with 6 times 3 right here. And we know 6 times 3 is 18, so what do? We move up the 6 beads because we're multiplying the 6, and so we can move that up and say we're done multiplying with the 6. Up above, we're going to move up 110, 8. So here's our 110, and there's our 8. So notice we have 18, 110, 8 at the top. Notice what we're going to write, though. We're just going to write the 8 below the 6 and the 3 that we multiplied. And that 110, we're going to write over the tens place. Okay? Well, that's interesting. What are we going to do about that? Right? So before we do that, think about what we did here, right? When we multiplied 6 times 3, our answer was 110, 8. Since we had 8 ones, we wrote that down below the 6 and the 3. Since we had 110, we put that 110 on top. And so what we're saying is, in the tens place, after we multiply, there's going to be one more 10. Or we can say, before we multiply, there's already 110 there. Okay? All right, so now let's multiply the tens. Okay? So when we multiply the tens, we're going to take 30, right? And if we look at our abacus right here, there's the 30. We're going to move that up. That's the 3 in the tens place, the 310. We move that up because we're multiplying by that 3. 30 times 3 is 90, right? 3 times 3 is 9. Since we're multiplying by 30, we'll add a 0 to our answer. So 30 times 3 is 90. So we're going to move up 9, 10. Notice that's being done right here. 9, 10 is being moved up. And notice that 9, 10 is joining the 110 that's already there. The 110 that's already there. Okay? So 9, 10 moved up to join 110 becomes what? 1010, right? There are 10 tens here. Okay, so what do? Well, since in 10 tens, there's a 0 in the one place, right? We put a 0 down here. And we can make the trade. We can bring down those 10 tens and we can move up 100. That's what's represented right here in this picture. We've made the trade. We brought down the 10 tens and we took up 100. Well, on our paper, what ends up happening is we write the 1 over the hundreds place. Okay? Again, what does that mean? It means that before we multiply the 700 to the 3, there's already 100 in our final product. Okay? So let's multiply the 700 to the 3. So let's bring down, or I'm sorry, let's move up the 700s to show that we're completing that multiplication. 700 times 3 is 2,100, or 2,100, however you want to say that. 7 times 3 is 21. We're multiplying by 700, so we put 2 zeros at the end. 2,100. So notice that 2,000 is being moved up there. 100 is being moved up to join the 100 that was already there. Where did that 100 come from? It came from the trade when we brought down 1010 and moved up 100. That trade came from all the way back here where we multiplied 30 times 3. Okay? All right, so now notice what we write down here. We have 200, so we put a 2 in the hundreds place here. Right there. We also have 2,000. By the time we're done multiplying 700 by 3, we also have 2,000. So notice we put the 2 over the thousands place. And so what does that mean? It means that before we multiply 2,000 times 3, there's already 2,000 in our final product. Okay, so let's take our last step here. 2,000 times 3 is 6,000, right? 2 times 3 is 6. Since we're multiplying by 2,000, there are 3 zeros that get added over here. Okay? 6,000. So what are we going to do? Well, we should move up the 2,000 because we're completing that multiplication. We should move up 6,000, and now that 6,000 is going to join the 2,000 that is already there. Right? Where did that 2,000 come from? Back here when we multiplied 700 times 3. Remember, that answer had 2,000. So before we multiplied 2,000 by 3, there was already 2,000 in the thousands place. We now move up the 6,000 from this multiplication, and what do we have? We have 8,000 total, and so we write the 8,000 in the final product, 8,208. So think about it. If we had written this out the way we did before, let's see if I can kind of represent this. We would have written, let's see, we would have written, whoops. We would have written 18. My one's a little bit small, but we would have written 18 there, right? And then we would have written, we would have written 90, something like this, below that. It's not working out great as I try to represent what we would have done. 90 below that. Oh, maybe I can. And then we would have written what? We would have written 2,100. Well, that's not working. Let me take that away. We would have written 2,100 below that. Something like that. Right? Because that was the 700 times 3. And then the 3 times 2, we would have written 6,000 below that. Okay, so we would have written all of this right here just to get to where we could then write the 8,208 for our answer, right? Because we would have added up all those partial products and we would have that answer, 8,208. So you can see that the way we did it here, right? Look at how this is, look at the final writing over here. Much less writing than over here, right? This was the way we wrote it when we wrote out the partial products, which is a perfectly fine way to do it. I mean, the point is not that it's wrong to write a lot, not at all. I mean, if it's helpful to write things out this way so that it's clear to you what's happening, then by all means write it out this way. But it's also helpful to have what we might call shorthand or shortcuts to writing out our answers. And if we can learn to write it out this way, it just helps us be more efficient. Okay? All right, so that's what you're doing on worksheet 19. Okay, is same idea. You got multiplication problems to do. You're going to work them out on your abacus, and you're going to write them down using this method here. Right? Remember, last worksheet was this method, the partial product way. This worksheet, we're going to write it this way, where we're just writing ultimately the final product without the partial products. Okay? One way is as good as another. You can see the advantage of being comfortable with this new way that we talked about it because it's less writing. But you can see the advantage of this way of doing it because you can see each of the multiplications, right? Now you might think, well, why is that an advantage? Well, let's suppose that you find out that your final product is incorrect over here, right? You see, let's suppose your final product turns out to be incorrect. It might be difficult to know where you made your mistake looking at this. Over here with your partial products, if your final product is incorrect, you might be able to find your mistake quickly just by checking each partial product, right? And then you can perhaps see where you made the mistake, okay? All right, so worksheet 19, do the multiplications on your abacus, side 2, like we did here. On your paper, write out your work this way, without the partial products. Okay? Enjoy!